All right, so today it's objective, this is the first objective of Unit 11. This is 11.1a. And today we're going over the sum and difference identities. And the essential question is, how can I use the formulas for sum and difference of multiple angles to find its exact value when it's not in a special right triangle? So it's like you won't see it on your unit circle. You won't see it on your exact value trig sheet that we created. So what you have to do is break that angle into two different angles that are on your unit circle or are on your exact value sheet. So I don't have time today to teach you why these formulas work, but I will post a video on Canvas if you're curious to know not just how to use the formulas, but why they actually work, okay? And so let's go with the sum and difference form identities. And for most of this unit, we'll just go sine, cosine, tangent. We won't do the cosecant. Well, we will with cofunctions, but pretty much everything else we'll just do in the basic three that you can plug into your calculator, okay? So we're going to start with the cosine of angle alpha minus beta. So it's a combination. This is the function here, this equation right here, formula that's created right here, is the basis for the creation of all the others. So we're going to start with this one, and it goes like this. The cosine of angle alpha minus beta, two angles, it goes like this. The cosine of alpha, cosine of beta, plus the sine of alpha, sine of beta. And I don't, like I said, right now I don't have time to explain to you why it is what it is, but I will post a video if you're curious. Okay? And then the rest of these you can basically build off of this formula. I'm not going to ask you to derive them. Let's go ahead and do the sum of angles here. So the cosine of angle alpha plus angle beta goes like this. Cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. So I would encourage you to take a look at those formulas and commit them to memory and make a connection between the sign that you see between the angles and the sign that's on the other side of the formula for cosine. So cosine, cosine, sine, sine. That's how you do the cosine angles. And if it says so you're doing the difference of angles, you're adding. And if you're doing the sum of angles, you're subtracting. So I encourage you to, like I said, memorize that. Let's move on to sine of alpha plus angle beta. It goes like this. Sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. Now, sometimes, remember that multiplication is commutative, right? So 1 times 5 is the same as 5 times 1. True? And please, I'm saying this on purpose because I put on the quiz tomorrow. I put the quiz that you're going to take tomorrow. I will rearrange these equations a little bit. It doesn't make them false if I rearrange them. So for example, I could write this as, instead of writing this as cosine alpha sine beta, I could write it as sine beta cosine alpha, right? Because multiplication is commutative. I can multiply in whichever order I want. So this is an alternative way to do that. When I do assign a sum of angles for sine, I will go sine alpha, cosine beta, sine beta, cosine alpha. That's just the way I remember it better. Okay. All right, let's go to sine of angle alpha minus angle beta. What do you think the formula is? Plus? It's plus when we're adding. Minus. You got it. And again, remember that the alternative could be cosine beta, sine alpha, minus sine beta, cosine alpha. I can flip these values around. Just remember that the combination sine and cosine sine times cosine, and sine times cosine is an expression of the sine of the sum or the difference of angles. All right, let's go to tangent of alpha. Angle alpha plus angle beta. You're going to like this one. Goes like this. Tangent alpha plus tangent of beta. I just changed my mind. You're not going to like it. Over 1 minus the tangent of alpha, tangent of beta. So at the beginning, it's pretty nice, right? Because it's just a duplicate. Pretty much tangent alpha plus tangent beta. And look what happened to the sides. If I'm doing the sum of two angles, it's addition on the top and subtraction on the bottom. So it stands to reason, I hope, that if I'm subtracting two angles, that I would put subtraction on the top between the tangent of each angle separately and addition on the bottom. So these formulas are similar to each other. You just really have to pay attention to the detail and what angle. What signage should you use, plus or minus? Questions about that? So another encouragement would be to make sure that you transfer these onto your Trig Identities index card, because I will not let you take out your notes when you're doing a quiz, but I will let you take out your ID index card, because I know it's really easy to forget which sign to use, plus or minus. Okay, moving on to just an even and odd identities review. I'm going to color code. I'm going to do the even identity in red and the odd identity in blue. You don't have to do that if you don't want. You could just label them even and odd if you want to. But could we close the door? Man, it's loud out there. Thank you, Ryan. All right. So which of these, one of them is even and two of them are odd. Which one's even? Cosine. That's right. So the cosine of negative x is equal to the cosine of positive x. Okay? Remember, even functions are symmetric on the y-axis. Right? So cosine of x is equal to the cosine of negative x. So cosine of a negative angle is equal to the cosine of that angle if it was positive. Switching to my odd functions, the sine of negative x, so the sine of a negative angle is equal to the negative sine of x. So you have to take the negative value for the sine of x to get the answers to be the same. Tangent is also odd, so the tangent of negative x is equal to the negative tangent of x. So just a little reminder of how those relationships work for your even and odd identities. One other thing I'd like to remind you about before we begin work, and that's the conversion from radians to degrees. It's been a while since we talked about that, so we need to bring that back up. So remember, when you're converting something from radians to degrees, you're taking the angle theta, whatever it is, and usually radians are in terms of pi, usually. And if I want to convert that to degrees, I multiply that times 180 degrees over pi. And it will tell you that when you're doing these angles that we're about to work on here, it's easier to work in degrees than it is to work in radians, because radians tend to be fractions and degrees tend to be whole numbers, right? So it's good to have this in your toolbox. So let's take a look at these guided examples. I would like for you to please note that I have changed problem B and problem C. So if you would please do that right now so that you're not solving a different problem than me. Problem B, I would like you to change to the sine of 5 pi over 12. So change the 7 pi to 5 pi. And then for problem C, I would like you to change the tangent of negative 7 pi to just positive 17 pi over 12. Okay, so tangent of positive 17 pi over 12. So if you have those changed, I'm ready to work. Instructions say this: find the exact value of each expression. Okay, hint, that says exact value, not approximate value. So that's where your graphing calculator is not going to be helpful, or a plain old scientific calculator is not going to be helpful. You're going to want one of those calculators that'll give you answers in radical form. Okay, so usually when you see find the exact value, that means that your answer will probably have square root in it somewhere, right? And so what we're going to do, we're going to find the exact value of the cosine of 285. Not with the calculator. The calculator knows how to do it all day long, but I need you to be able to do it. And so we're going to use a sum formula and a difference formula for each problem so that you can see, you can verify that the formulas work, okay? And you can go back and rely on angles that you know a lot about, and those are the angles that are on your unit circle. 285 degrees, not on your unit circle, right? So here's what I'm going to do. I'm going to do a sum example on this side, and I will do a difference example on this side. So we're going to start with breaking the cosine of 285 degrees into two angles, the sum of two angles that add up to 285 degrees. So I'm going to write a little statement. I'm going to let 285 degrees equal, and then I'm just going to pick two values that I know are on my unit circle that will add to 285 degrees. Now you could come up with a different pair of angles than me. So think about that. Which two angles could I add up on my unit circle that add to 285? You got one? 150? 150 plus 152 is not on your unit circle. Okay, I got it. 150 is on your unit circle, and 135 is also on your unit circle. So that one would work. See, I was thinking 240 degrees and 45 degrees, which are also two angles on my unit circle that add up to 285 degrees. But we'll go ahead and they'll give you the same answer. So it doesn't matter because these formulas always work. So we'll go ahead and go off Joey's suggestion. I like it. So we are going to, instead of do cosine of 285, we're going to solve the cosine of 150 degrees plus 135 degrees, and we're going to use our formula to help us find the solution. Are you ready? So what's the formula? If I'm doing the cosine, sum of the cosine of two angles, it goes cosine of 150, cosine of 135. Please put degrees on label with degrees, because otherwise you're telling me radians, which is 150 radians is a lot of radians, right? All right, and then is it plus or minus? Look at my sign, minus, and then we do sine of 150 degrees, cosine of 135 degrees. So you have your exact value trig sheet ready to go. You're ready to tell me the exact value. It is sine, thank you. Oh, I was just testing you. Okay, so what's the cosine of 150? Exactly. It's got to be like negative square root of 3 over 2 or negative 1/2. I don't remember which one it is. Negative square root of 3 over 2. And the cosine, I do remember this one. Cosine of negative 135 is negative square root of 2 over 2. So I'm going to multiply those two guys together. And then, so the sine of 150 has to be 1/2. And the sine of 135 is positive square root of 2 over 2. So I get all those values. I can find those. I know those. I got them memorized pretty much. Now I just need to simplify this. Ready to go? So negative square root of, so I'm going to do my multiplication before I do my subtraction. Negative square root of 3 times negative square root of 2 is square root of 6. And 2 times 2 is 4. So that's the square root of 6 over 4. Yes, you can multiply radicals. If they're the same kind of radical, they're both square roots, you can multiply their radicands. And then you're multiplying over here. Half times the square root of 2 over 2. So 1 times the square root of 2 is square root of 2 over square root of, 2 times 2 is 4. Sorry about that. All right. Now, all we need to do is simplify that. So these have the same denominator, right? So that means I can write them as a single fraction, but I cannot combine the square root of 6 minus the square root of 2. They're not like radicals. And so my exact solution would be this. The square root of 6 minus the square root of 2 over 4, that is the exact solution. So I'm going to give you a moment now to check that with your calculator. So I'm going to press pause. So now I'm switching to my blue pen, and now I want to prove that not only does the cosine of the sum of two angles work and give you the exact answer that the calculator gave you, but I can also use a difference. I can use a subtraction of two angles. So first, I'm going to come over here to do a little work. We're going to let 285 equal two angles, and I'm going to take their difference or subtract them. So I'm just looking for two angles on my unit circle that would subtract to 285. What you got, Isaac?
330 and
330 degrees minus 45. Did anybody else have a different one? That's a good one. What about 315 minus 30? That would work too, right? So there's multiple answers that will work, but we'll go ahead and use the one that Isaac suggested. So we're going to do the cosine of 330 degrees minus 45 degrees. And my intention here is to have you practice using the right formula, plug in the right sign. We'll do it by hand one more time. So here we go. Cosine of 330 degrees minus 45 degrees goes cosine of 330 degrees, cosine of 45 degrees. You tell me the sign. Plus sine of 330 degrees, sine of 45 degrees. Woo, I'm running out of room. Okay, so ready? Exact values. What's the cosine of 330? Square root of 3 over 2, and the cosine of 45 is the square root of 2 over 2, right? Plus, and the sine of 330 must be negative half. Yes? And then the sine of 45 is the square root of 2 over 2. Man, I'm looking at the same problem. Right? This is, if I simplify this, the square root of 6 over 4 plus negative square root of 2 over 4, which simplifies to the square root of 6 minus the square root of 2 over 4. And so I hope that that illustrates that these formulas work and that you have the ability to do this without a calculator. You don't need a calculator. If you have your if you know your 30, 60, 90 and your 45, 45, 90 rules, and you know when sine is positive and negative, cosine is positive, negative, you can do this. Okay? Now, I am not going to require you to always go to the final point where you're plugging in the exact values. I will not always ask you to do that, but I will ask you to do it sometimes. So don't rely too heavily on your calculator to do all the heavy lifting. Yes.
on the quiz, do we ever specify like which one would be like the sum or the difference?
Well, you just specify it with either using a plus sign or a minus sign, right? It's a multiple choice thing, so you're just picking the answers that are the correct formulas that go with the correct things. So basically tomorrow what I'm asking is, did you understand the basics of what I taught today? Okay, so here we have the next problem, the sine of 5 pi over 12. So this is in radians. 5 pi over 12, not on the unit circle. And I don't particularly care to think of the two radians that will add to 5 pi over 12. You might want that challenge. I'm not interested. I would rather convert this to degrees and work in degrees. But that's my preference. What do you think? Degrees. Okay, so let's convert real quick. 5 pi over 12 times 180 over pi. Cross simplify. So basically we're doing 5 times 180 over 12. You got your calculator? And we get sine of 75 degrees. Right, 75? Check me out. All right. So we're going to do a sum and a difference. So let's do a sum first. We're going to let 75 degrees equal. You pick two angles that we are going to add. This one's so hard. 30 and 45. Those are definitely on your unit circle. And let's go ahead and pick our difference as well right now. We'll let 75 degrees also equal what if we do 135 minus 60? Or 120 minus 45, that would work, right? So multiple numbers that would work there. And we're going to expedite this process now, though, by not plugging in the exact values, but just plugging in the modified formula. So let's start with our sum. So we're going to do the sine of 30 degrees plus 45 degrees. And then you're going to tell me what's the formula for that. How does that look? How does it go? Sine of 30 cosine of 45 plus cosine of 30 sine of 45, or sine of 45 cosine 30 if you wish. This time, I would like you to plug that into your calculator instead of the exact values, because sometimes maybe that's all I want from you. Is can you show me that you know the proper formula to use? Calculator knows how to do that math too. So I'll give you a minute to. And so you've had time to plug that into your calculator, and you got the square root of 6 plus the square root of 2 over 4. Okay, and then quickly switch to your other color, and let's just go ahead and do the difference. So we're going to do the sine of 135 degrees minus 60 degrees. And again, this time all I'm concerned is you're using the right formula, you're using the right sign. So how does it go? It's a difference. Cosine 60 minus cosine of 135 sine of 60. You got it. Plug that into your calculator. I bet it tells you exactly the same thing. And you know what's great about that? Well, you can kind of copy paste the last problem and just change 30 to 135. Well, I don't know, because you might have to insert numbers. Might be just as fast to type it in again. What do you say? Yep. Square root of 6 plus square root of 2 over 4. And again, just reiterating, all I'm trying to do is to drive home the idea that these formulas always work, and you can choose any angles on the unit circle that you want that add or subtract to these angles that you're being asked to find that are not on your unit circle. Okay, so last one here. On the front, we have tangent of 17 pi over 12. Again, I don't like working in radians if I can work into degrees. So let's convert 17 pi over 12 into degrees. So basically you're doing 17 times 180 over 12, right? Because pi is 180 degrees. Simple. So we're doing tangent of 255. I almost wrote 25. All right, 255 degrees. So for finding a sum, we're going to let 255 degrees be a sum of 210 and 45 would be good. I like that. And then let's find our difference too. So we'll let 255 also equal 300 minus 45. 300 degrees minus 45 degrees would also work really well. Don't be discouraged if some of these people are doing this math faster in their head than you do. Don't worry about that, as long as you can do it. Okay, so I'm going to go ahead and let you try those, and I'm going to press pause on the video, and then you can come back and see if you were able to do the tangent formula with a sum and a difference on your own. So take a look at what we've got there. We did a sum example and a difference example, and both times we were able to get the solution, the square root of 3 plus 2. Okay, so if you don't have questions, then what I'd like to do is quickly do the two problems on the back and what they're doing, and let me throw this away and we'll start over here from, there we go. All right. What you're being asked to do here is kind of work backwards. Okay, so here you're asked to express as a trig function of one angle instead of multiple or two angles. So what I like to do is just take a look at the format, look at the expression, and think about which, is it a sum or difference, and is it cosine or sine or tangent, which one is it? So let's take a look at it. It's cosine 48, cosine 23. That leads me to believe this is a cosine. Yes? And then plus sine of 48, sine of 23. So that leads me to think that this is a difference of two angles. And I can see the two angles here, right? And remember, that's how cosine works. Cosine, cosine, sine, sine. And if it says I'm finding the difference, I add their answers. Okay, so this would be, if I were to simplify this and work backwards, the cosine of 48 degrees minus 23 degrees, and then take that down to one angle, cosine of 25 degrees. Not really difficult, just working it backwards. What do you think? I gave you way too much room for that problem. All right, here's the thinker. You got this problem here, and I look at it and it's sine, cosine, and I'm like, okay, so that's definitely a difference or sum of sines. But here's the problem. I see three angles in radians. I see an angle of -2, an angle of 3 radians, and then an angle of 2 radians. So there's 3. I have a formula for that. But if you recall, I did give you some additional formulas to review. The even and odd identities. Do you remember that? I did. And I would really like to just see two angles up here, like 2 and 3, or -2 and 3. Because here's what we know. 3 matches. Right? So what I'm wondering is, can I make this cosine of 2 into a cosine of -2 so that I can use the sine of -2? I can. Right? Oops, I don't want that. Oh, hey, but now I could add more colors to my tools. How do I do that? I got to remember what button that is. Okay, so that's that button. All right. I've been looking for that button for a long time. All right, so I can apply an even identity right here, right? So I'm going to put even ID here. And that even identity says that the cosine of -x is equal to the cosine of +x, which means the cosine of +2 is also equal to the cosine of -2. So I could replace this with the cosine of -2. So you got to think a little bit when you solve this problem. So here's what we have. We have the sine of -2 radians cosine of 3 radians minus the cosine of -2 radians sine of 3 radians. Okay, so which is this a sum? A sine sum or a sine difference? Sine difference. So it goes sine of alpha minus beta, right? That's the formula. So this is the format. So we're going to do the sine of alpha, which is -2, minus beta, which is 3, and that's the sine of -5. So it's angle -5. Or if I apply the odd identity, the negative sine of 5. Both are acceptable. This is just an application here of an odd identity. And the reason I'm pointing that out is you're going to be verifying things soon. So I want you to always be thinking, can I use an identity to simplify this? Either answer would be acceptable there.